Thank you once again for joining this session. We are going to start logistic regression in today's session. The agenda of today's topic is perform linear, but not the linear regression, but logistic. Right? What's your objective for our session? Predicting if a person would buy life insurance based on his case using logistic regression. Right? So what kind of data set we are having, what kind of operations, uh, digital conditions we are dealing with, pandas, matplotlib library, which library we will be using. So we will cover all these topics. Along with this, we will cover the mathematics behind logistic regression also. How this is improving linear regression drawbacks. So first we are allow me to import basic libraries here. So we have basic libraries called pandas, which is panel in data, which is most widely used in Python. The second library we are going to use from matplotlib. I'm going to import pyplot as PLT for various plotting, various graphs and so on. And then finally we are going to write matplot matplotlib, and it's going to inline so that we don't have to write the grid function and other prerequisite again and again, right? So let me write or inherit the functions here. So this function will include all my data frame. So what's the data frame? PD is alias name for my pandas data, and I'm going to read underscore CSV, and this CSV is just taking insurance data set. So insurance underscore data dot CSV and hit run. So it's not showing any error. This means in my this one in my Jupyter notebook, in my shell script writing, this function, this file is already there. You can see it's already there, insurance.csv. It's a comma separated value where we have rows and column, right? If you'll just check or open in another tab, so it will depict the age of the respective customers and whether they will buy insurance or not. For example, we have health insurance, we have motor vehicle insurance, we have prediction a particular person is going to intend the policy in towards buying or not. So this is a realistic example, right? Now we are going to, we have already installed this library, we have already we stored on the on the left hand side. This df is consisting all my data set. So how to check this df dot head? So we are getting all these comma separated value over here. So first is age column, second is bought insurance, and on the very left hand side you can see index value for respective records. So each row is called record here, right? So we have records here. So how to access the records here? Like let's say you have df2, so you can see this this df.2. It's not showing. Let me take this df round bracket. No, okay. So let's take df dot head. Somewhere I'll take df dot head. So let's say 5 or 3. So it will show first 3 records for my data set, right? Similarly, if you want to check random samples, so for this we have sample record and we are going to select 3 sample out of the box. You can see this is going to select randomly. Next part, what's the shape of my data set, right? How to find the shape of, so for this we have shape function, and this will depict the rows and column, right? This, so round bracket is not here. Make sure you are not including round bracket in the respective function. right? It's not the respect function, it's just command there. So we have 27 records, two columns. A is bought insurance respectively. Records we have finally 0 to 26, we have 27 records, right? Can we have graph over these simultaneously values? So for this, I'll write pl2 dot scatter. The plt is taken from matplotlib library. You can see the alias name for this, and it's going to inherit that scatter function. And along with this scatter, I'll take the first column. This is the continuous value. Why I'm having continuous? Because it can have any age in between 21 to 100 or beyond 100 also, right? So the age factor can have in float also, like not in the round of value, you can have float values also. So there is no finite values in between age domain. Therefore, it is called continuous dataset. This graph is plotted in between df.age and df.next part. So what's the next part? This part is bought insurance. Make sure you are writing the correct spelling, correct word. Even a single word is mismatched, the error will be thrown on the screen. So we are going to create marker, and this marker is just taking plus sign over here, right? I need every plus sign, any dot will be represented by plus sign. So what should be the color of my marker? So that would be color is equal to, that would be red here, right? So let me create this plot. You can see this plot is just written over here, right? So can I open, copy or edit image? Yes, I can edit image here. But why I'm adding here? Because you can see my particular value. If I'm going to mark or something readable here, if I'm going to create any linear graph here, linear equation. So what's the responsibility of linear equation? It will create a simple line in between these points. So passing through these lines, and will try to make something awkward, like something relevant to y is equal to mx plus b. This is the line equation where m is the slope and b is the interception across y axis, across vertical axis. So we are getting y is equal to mx plus b as the final line, and any unknown data. So what do you mean by unknown data? Let's take another point over here. Let's take plus sign. So if you will ask any plus sign over here, so this is the unknown data for us, and we are going to predict for this new testing purpose. So you will have this A's, and we are going to predict whether he will buy or not, right? So let's say this plus sign is having A's. Obviously, it will acquire the X value, and X value is nothing, A's, etc. Right? Let's say this is having 25 years old as an primary factor. So we will know the value of M, which is slope here. We will know the value of M, which is intercept over Y if it is passing through origin. So the value of B will be 0. But here we are getting only some positive or negative value, right? So this line will passing through all these data set and try to accommodate all these value on X and Y axis. But our objective is to predict for new data set. This is going to predict for this candidate who is having AS 25. So we are going to predict this AS factor into the 25, and remaining value will be there. So Y would have some value. But problem is there. This equation, Y equation, will have so many data set far away from this line. Can you see? These points are very far away from this line, which is not very clearly suitable or clearly this one passing through this line. Also on the left hand side you can see so many data points are very far away. The distance between this line and the data set is very high. Uh, when you go down along the zeros, like because we have all the zeros value, where here we have all the one value, you can see over here this is all the one value, this is acquiring all the zeros value here. So along the left hand side, below left hand side, you can see these data set also very far away from this. Far away means accuracy is very low. Our testing and our margin or error data set will be very high. The R value or root mean square value will be high. So there is a clear trend over here. In order to reduce the accuracy, all these data points should pass through the particular value, particular line which has been created by our model y is equal to mx plus c. But that's not happening over here. This is the first reason we are going to avoid linear regression and choosing logistic regression instead, right? So I'm going to save over here and just it's just downloaded my file and just close it. All right. Did you get the mathematical background around this graph? Because in the linear regression, the data set is scattered along all the ways. But here we have orientation towards 1, orientation towards 0. Why? Because can you see this bought insurance? They they are buying the insurance means value 1. They are not buying insurance means the value is 0. Right? This is the reason this data set is biased or having some orientation towards 1 and 0 only. No other choice are there in my binary classification or binary target column there. So for such kind of data set, we use logistic regression because the line itself cannot fit the data set. If you are deliberately, if you are fitting any line, so you can see the drawback over here. We will have so many points far away from our predicting line. So we are talking about logistic regression. How we are going to implement this logistic regression? We will use sklearn library. So this sklearn will acquire this model selection. So I'm going to use model selection. So what's the model selection here? So model selection, we are talking about train, test, and split. So what is this train, test, split? I'll explain in few minutes. Let me run this code first. So from the sklearn library, we have model selection model or module, and we are importing this method, right? Then we are going to segregate this entire data set into 4 parts, and these 4 parts is x train, second part is x test, third part is x y train, fourth part is y test, and this will be automatically uh, differentiated by train test split method. So we are just supposed to pass the method value, and this method value will acquire the target feature value only, and then df dot df dot the target column here. So we have bot reference reference, and then train underscore size is equal to 0.8, right? So let me run this code and let me check whether this is properly splitted or not. So x train is just over here. So we are going to check. Yes, beautifully it's just separated over here, and you can see the index values are also randomly here. So can I check x test value? So yes, we have already x test, right? If you'll focus that x is consisting the feature value, right? And y is consisting only target column, right? So let me come over here, like why we are splitting these two things, because we have two things. These two things are called testing and training, right? Let me open this file. Okay. So we have just entire data set which is stored in a df file, df variable, right? That's fine. This df variable is consisting is, and this target column is called bought insurance, whether he will purchase the insurance or not, right? We have divided this entire data set into four parts. So let me create this line over here. This is the oh, all right. This is the first line, right? And let me create the another vertical line over here. So this is the vertical line, right? And let me create little bit below, because we have something. So along the vertical axis we have this. So it is right. Now let me write their ratio according to my code. So at the above we have 80%, which will go for the training. I'll train my model using this 80% data set. For the below part, I'll go for the testing purpose. I'll test my model whether it is performing well or not. It is overestimated or underestimated. These technical terms we will use, we will explain or illustrate in upcoming sessions. But as of now, you must understand we have 80% data set for training, we have result, and 20% data set for testing our model. We are training our entire algorithm to go with this as is key terms only and give this target value whether they will purchase or not. Once we have created this model successfully, now I'll check the model accuracy using this 20% testing data, whether this is close enough to provide 0 and 1 bot insurance data set. So this will perform binary equation, like whether we are having good accuracy or we are having bad accuracy. So this testing purpose is accomplished over there. The purpose of our 20% split is to train our model on the basis of first part. This is 80%, and for the rest 20% we will give our accuracy. We'll check our model accuracy, right? If it is very low, we will start from the scratch. What other hyperparameters we can tune or we can talk about, right? But as of now, you can see this is the first part. This is the second part. Here we have third part. Here we have fourth part. So on the basis of this statement, I just given that statement, like just stated that we have divided the entire data set into four parts. Why four parts? First, we have is, that is feature value. Second, we have target value. We have again feature value. We have again the target value. Can you see? These four are respective partition of my data set, and on the basis of given condition, we we have this. Oh, okay, here we have. So on the basis of given condition, where you can see 0.8. So this is just dividing the entire data set into 80% in it. If you'll give this value 0.5, so 50% will get 50% data set will go for training and 50% will go for testing. If you will, so generally we divide into 80 to 20 ratio. So this is the general ratio or general method, right? So question. So I am just going to proceed here. So finally, we have already created. Let me revise one more time. We have, yes. Anyone having any question? So on the basis of this logistic regression, we have already splitted the single data frame into four parts. First is X train, second is X test, Y train, Y test, right? And we have seen the values of these are just single column, right? If you check Y test, you have only target value. If you just Y train, so you have 80% of this data set, right? If you'll count these values, so certainly they will be 80% of the entire scenario, right? But the next part, how to predict for the certain outcome. So we are going to predict this one is equal to model dot predict. This is predefined formula, predefined function, I would say. And for X test, I'm going to predict what's the accuracy on my test data set, right? So model dot, oh, I'll have to assign or create my model. Sorry, I didn't create that model first. So first I'll have to create my model. So from scale learn dot linear model. I'm going to import my logistic regression. So, and finally we are going to create the object of this logistic regression. Let's see regression and the part of this just created, right? So on the basis of given logistic regression, I just tested my data set, and you can see this logistic fitting called fit. Okay, so oh, I didn't fit my data set either. So I'm going to train my model. So this is going to inherit this model dot fit and x underscore train and then y underscore train. I'm going to train this model first. This is just predicted, and finally I'm going to predict this one, right? So if you check the output of this prediction value, so you will see something 10101, right? On contrast, if you will check the test value, so this is the on the base on the encounter of y test, the model is predicting these respective values. So let me check one by one. My first is 1, first test is actual data is also saying 1. This is this customer will buy the product. Second customer will not, here is also not predicting, it's not, it will not buy. Third prediction is 1, this is also giving 1. Fourth prediction 0, we have 0. 1 is here, but here we have 0, which means this is the wrong prediction. The model is giving wrong prediction as compared to original data set. So we are just going to count it as a false positive, means we are getting wrong value here, right? Finally we are getting 0, the actual data set also says 0. So out of the 5, like out of the 6, 1 upon 6, we are getting one output wrong. So can you see this, how many, like 5 upon 6, so this is the error 0.1677. If you check 5 upon 6, 83%. So 83% is my accuracy, the training accuracy is 83%, right? So this is how you just check the model accuracy, right? Now suppose if you want to check the model score, how it is going to score this value, so you can go for the score value here. So as compared to X test, we have Y test, right? So you can see it's also giving 83 points. So this is the reason we just calculated manually. But most of the times you have testing data set in the thousand numbers, in 10,000 or sometimes 20,000 or 12,000. You cannot count in that case manually. So this is the tiny data set. So we are calculating very easily. But on the so as far as very large data set is concerned, you cannot go for the that distribution, like which data set, what's the accuracy, what's the model score versus X versus Y test, right? So for this we have model dot score method which is giving the accuracy of my value, right? All right, can I check the model coefficients, right? So what's the model coefficient? So for model, what's the model coefficient here? Model coefficient indicates the value of y is equal to mx plus b, right? Or some sigmoid function you can see, right? So similarly, as we have y is equal to mx equation in the linear regression, here we have something different. So here we have sigmoid function. I'll come with the sigmoid function also. We have sigmoid function represented as 1 upon 1 plus exponential of x, right? Now let me check the value of this 1 upon 1 plus. Why we are taking sigmoid function in the logistic regression? Because when you go for the Google aspect, you just go calculate the expression value over here. Going to wrap it in the count bracket, and finally this is just printing. So let me put some x value here. So 1, we put 100, right? So can you see it's a more like 10 towards, like if we'll check the value of 10 here, so it's a 10 towards 0, right? So what's the meaning of this one? What's the function? Function says when we have fx, what's the equation of fx we have just taken? We have taken 1 upon 1 plus e raised to the power minus x, right? So for x raised to power minus x, when we have minus of 10, so obviously minus of 10 would be somewhere 1 upon 1 plus e raised to power x, right? So we have value 10 towards 0. So this is almost equivalent to 0, I can say. Similarly, if I check for plus 10, so obviously this would be 10 towards 1. Can you see the value is approaching 1 here? So what can I interpret it in? I can say, illustrate over here, f of 10 would be almost equivalent to 1. Let me check another values also, right? So what other values are giving values with respect to the same equation? Let me check for f is equal to 3 minus 3 here, and f is equal to 3 then. So here f is equal to minus 3 will give value towards 1. Can you see? It's going to give value towards 1. So we have 1 here. So the equation is itself saying minus 1. So minus minus plus, right? Then we have expression of 3. This would be near about 0.05 or something 47, you can see, right? So this value, like when you put in the crux of the equation is the statement says this equation is either giving value approaching to 1 or approaching to 0, right? All right. Suppose you want to create the expression for this. How to create the expression? You can see your math problem is this one. You can see the graph itself saying we are having the most of the values towards 1 and most of the values towards 0. Here you can see its intercept value 0.1. So you can see on the either side, when the value is above 0.5, so this will fall towards he will purchase the insurance. When this value is below 0.5, he will not purchase the value because it's approaching 0 over here, right? This is the reason we are going to use this value so that we can get the value near about 0, 1, 0, 1, 0, 1 every time. So this will be parameter over here, and you will be getting that kind of output there, right? So any question, any answer, prediction value, you can go for the counted value, right? My prediction is saying, my output is saying the last one is saying my prediction is 1 and my actual is 0, right? So in this case you can see my prediction is positive but actual is negative, right? So you can see this is the false positive value, right? Similarly, in the reverse condition you can see this is the false negative, right? So all the correct values, right, are represented by TP and TN, the confusion matrix, and all the false prediction, right, either like either this is mismatch, like all the mismatch values here, like 1 2 3 4, and the last values are matched one, right? So you will say like this one is a matched, right? But when we have mismatch value over 1 here, 0 here, so we will call it this red conditions here, and all the matched value will be represented by green. And yes, we can go for the this one confusion matrix, because we are predicting for classification problem. And first we are going to predict some regression value, and find then we are going to assign some some point, like if the value will be beyond 0.5 and the below 0.5, then we are going to perform in the classification problem. And this is the classification problem. Any other question, any other query?